The original rationale behind this observation was to examine the slopes for changes since an earlier image in the same location. However, a feature that has not changed much since then still remains quite eye-catching. Multiple boulder tracks can be seen spilling down the side of the crater. When boulders roll down a dusty Martian slope, they can leave long, dotted tracks behind on the slope's surface. Boulder tracks, like slope streaks, can be either brighter or darker than the surrounding terrain. The many boulder tracks in this image all seem to emanate from a small alcove near the rim of the crater. They spread out downslope and finally terminate near the crater floor. A high contrast stretch of the area where the track stops shows lots of boulders, some still at the ends of the tracks. High Rise has seen boulder tracks fade over time in other locations. However, as compared to another image taken 3 years ago, the tracks in this image don't seem to have faded as dramatically as that earlier example, despite a larger lapse in time between images. This might be because the crater in this image is in a less dusty area of Mars. Curiosity rover took this image when it ascended a steep slope part of a geologic feature called Green Hue Pediment. In the foreground is the crusty sandstone cap that stretches the length of the pediment, forming an overhanging ledge in some parts. At center is the clay-bearing unit, a region with a unique story to tell about the history of water on Mount Sharp, the 3-mile-tall mountain Curiosity has been ascending since 2014. In the distance at the top of the image is the floor of a Gale crater, which is 96 miles wide. An elongated crater with a rock spire in it can be seen in this panoramic view. The shallow crater is about 34 meters long and about 24 meters wide, with a floor slightly darker than surrounding terrain. The rocky feature toward the far end of the crater is about 2 to 3 meters tall, rising higher than the crater's rim. The unusually shaped crater lies on the outer portion of the western rim of Endeavour crater. Endeavour's elevated western rim extends northward to the left from the crater in this scene, and a glimpse to the far side of Endeavour is visible on either side of the rock spire. This patch of wind-blown sand and dust downhill from a cluster of dark rocks is located in Gale Crater. When the X-ray diffraction analysis of Martian soil was performed here, the results revealed the presence of several minerals including feldspar, pyroxenes and olivine, and suggested that the Martian soil in the sample was similar to the weathered basaltic soils of Hawaiian volcanoes. NASA scientists also reported that Curiosity rover detected abundant, easily accessible water 1.5 to 3 weight% in soil samples at the location. In addition, NASA reported the rover found two principal soil types, a fine-grained mafic type and a locally derived coarse-grained felsic type. The mafic type, similar to other Martian soils and Martian dust, was associated with hydration of the amorphous phases of the soil. Also, perchlorates, the presence of which may make detection of life-related organic molecules difficult, were found, suggesting a global distribution of these salts. This is Endeavour crater, an impact crater located in the Meridiani Planum region of Mars. Endeavour is about 14 miles in diameter and averages about 200 to 300 meters deep. Phyllosilicate-bearing outcrops have been detected along Endeavour's rim, minerals which may have formed under wet conditions in a low acidic environment during the early history of Mars. There are raised rim segments to the north, east and southwest of the crater, and the rim has become worn, rounded and degraded, with infilling of plains material in a manner similar to Victoria crater. The plains surrounding the rim show evidence of polyhydrated sulfate, and the crater has undergone various erosion processes, with wind being one cause. When compared to the surrounding plains, the crater floor shows an enhanced spectral signature of basalt and hematite. The interior contains two groups of dune fields, and images taken since 2008 show evidence of changes in some of the associated formations, which may be evidence of active erosion by the Martian wind over a period of 2 to 3 years. These small ripples, about 10 meters apart, are located in Reddish valleys. Reddish is a small channel that shows evidence of phyllosilicates, which are silicates with a sheet-like structure such as clay minerals. Much larger images of this area show that Reddish valleys appears isolated with no obvious connections to craters or larger valleys.